Okay, so we're gonna pick up right where we left off the last time. And I want you to remember that here's some facts real quick. There will be 0 volts across a closed switch. The voltage reading across the windings of a de-energized motor will be 0. An ohm meter can be used to check switches and loads if all power wires are disconnected. Do not check with an ohm meter if it's still hot with voltage. Infinite reading means it's an open circuit, and never use the ohm meter on an energized circuit. Once again. Now, what is a pictorial diagram? This is in your book. It's used to show the location of circuit components. Some people like pictorials. Diagram configured to show the circuits as they are seen in the actual unit. Usually the wires on this diagram are color-coded in the diagram to make wire identification easier. All wires and connections are included. That's a pictorial. What's a line, ladder, or linear, they call it. It shows the circuits and component functions. It's easy to use, as each circuit is on a separate line, ladder diagram, of course. Lines representing the power supply are on the left and right sides as vertical lines. Power passing and power consuming devices are on horizontal lines between the power lines, okay? So let's go ahead and I'll talk to you real quick about what all that means. So let's look at this right here, this diagram. I like a line diagram and a pictorial. I really like a line. But you can see right here, if we want to do a quick survey of a circuit, let me come around this side real quick. I'm gonna get my OTC orange ink pen out, and it even says OTC because Oklahoma Technical College rules. Now look right here. Let's say there's a 3-phase compressor and motor, and I wanted to know which wire run was wired up on outdoor fan motor. Well, that wire should be going to what? L1 on the contactor. L1 on the contactor should be going to that. T1 on the contactor should be going to L1. L2 is common, and T2. Because notice between L1 and L2, you have a PSC motor. Okay, so none of this motor right here is hooked to L3. L3 is never coming contacting with this motor, but notice it is with this compressor. But let's find that same circuit over here. Well, I'd have to find L1 on my contactor, follow it, all the way back to run, and it goes to my fan motor. But you can see how quickly right here I saw run went right to L1. But notice when you're doing pictorials, they can be quite confusing because you could even cross a wire and end up in the wrong place. I do like pictorials, but they're not as fast as I can survey or come up with a synopsis with a line diagram. That's really fast. I'll be giving you all these handouts when we come back from school with all the legends and everything. And I got tons of single and dual transformer handouts to give you. Look at all the handouts you're gonna get, man. You're gonna have so many handouts, you're gonna wish you had more hands so you could hold them all. Now, I do want to go over those thermostats with you that can be tricky. Guys in the field can get tricked up sometimes not understanding what? The difference between a dual and a single transformer system. We're not scared of that though here at OTC. We're gonna get right into it. All right, first, let's just talk about a regular single transformer wiring. Right there. Don't be looking at that double one yet. No, don't be doing that. We ain't there yet. All right, so we know we got power coming into R, but notice most thermostats now come with RC and RH, okay? You looked a little crooked there. Some of y'all just crooked in. So here's RC and RH. We know we send in power to Y, which will energize our outdoor contactor coil. And if it's on cooling, it will also energize the reverse and valve relay, which both go back to common, which is hooked to that side. Now, it'll also, follow along and energize those two, it'll also energize my fan. So all that comes on at the same time. Now, RH is connected to W, which is my heater relay coil. And the fan will come on with my heater depending on what kind of furnace it is. And the other side goes to common. Just like that, boom. Now I want you to recognize that the terminal B right here for O is a heat pump terminal. RUD, R-U-D-D, or RUD, they use the letter B instead of O. So you have to pay a little attention to that. The other terminal you might run into is E for emergency heat. The only other one you'll run into sometimes, that you'll see sometimes, is Y1 and Y2 and W1 and W2. So that's first stage cooling, second stage cooling, first stage heat, second stage heat. Okay? Normally these colors are about the same. All right, I wrote them down right here. Most of them is a red wire, G is the green wire, yellow for Y, but they'll use light blue for Y2. Okay, O for orange, RB, okay? Here, white is used for W. They'll also use brown for W2. All right, common, they usually use dark blue or black. And depending if you got that too, E has no universal color. Dark blue or black. Now, I will give you handouts when you come back to class explaining all that to you in detail so you can bring it in the field. So notice R and C here are normally not connected. But when you buy the thermostat, you'll notice there's a red wire jumper in there. Well, that's sending power to heat and to cool, depending on which one's selected. So in actuality, R is actually connected to both of these. And if your thermostat picks heat, it sends the power that way. If it picks cool, it sends the power to Wyoming. But some units, because they're really big or they have a long run, will have an outdoor transformer too. And that can get really confusing on guys out in the field. You have one transformer indoors and you have an outdoor transformer. Well, the outdoor transformer, look at it like this. If it's in the condensing unit, it must have something to do with the condensing unit. So let's go ahead and look at that now. Here is the drawing I did of the, come on man, stop. All right, can you see that? Let's see. Is everything on there good? Okay, let me see if I can get a little more light for you. Okay, is that brighter? Yeah, okay, so let's look at this now. Here's an outdoor transformer, indoor transformer. And here is my outdoor transformer. We know this one's going to be for the contactor and the reversing valve. Okay, outside. The indoor will have to be for what? The indoor heating system, because that's for the cooling system. So now we take the jumper that was on here off. If you have a dual transformer system and you open up that thermostat, you need to take that red wire jumper off between RH and RC. Now, my indoor will send power to heat, which will energize my heat relay coil through W, and is my common and my blower. Notice the outdoor transformer now. One wire goes to RC, which will then energize what? My contactor coil, my reversing valve, and common goes back to that transformer. So here's a dual transformer system and how it's hooked up. And guys, it don't get much complex than that in residential. If you understand those ladder terminals right there for low voltage thermostats and the way a dual transformer system's hooked up, there you go. There you go. All right? Any questions about that? No, I ain't no question about that. Okay, you sure? Yeah, I ain't no question about it. Okay, good. I'm glad y'all got that. So we went over pictorial, we went over line diagrams, and we went over thermostats and the terminals. And you'll be getting a lot of, the next video will be on what? Direct digital controls you have. Now, would ask you to do this in your book. Read service call number 1. See that? It says it right there. Service call number 1. Service call number 2. Service call number 3. Those are good service calls to read. And then you may have a, in your homework assignment, you'll have service call 4 and 5 and 6 to do. No, it just says 4 and 5. So that's your homework assignment right there. There's your wiring diagrams, and you'll have to figure out that problem and offer up the solution. Okay? So there is your homework assignment. Do we have any questions for any of this? All right, guys, y'all did really good. Thank you for coming back.